So let me first give a brief note about what is the education or the Society 5.0. The definition by the Japanese given a human-centered society that balances economic advancement with the resolution of societal problems by a system that highly integrates cyberspace and physical space. So there are a few things here. One is human-centered. The technology should be human-centered. Then the economic advancement or the technological advancement should cater to the problems of the society. And the third one, it should be integrated with the cyberspace to the physical space. So these three things are the main aspects of Society 5.0. So today we have Dr. Subramanian, who is going to talk on role of technology in a connected world. As we know, people are connected through phones and internet. Almost, I believe, most of the people around the world will be connected through this. In addition to that, things will be connected. So we say things, it can be any things apart from people. So anything can be connected now. So through the IoT, you can connect anything. Each thing will have a IP address. So everything will be connected. Things, people, everything will be connected. So what is going to bring this technology to the society? There will be huge data generated by the people and things. So how you are going to handle this? Is it really beneficial to the society? So that's the idea of this talk. Dr. Subramanian is going to talk on this. Let me read his CV. It's quite long, but I will just summarize some of the important ones. Dr. Subramanian D.K. is the retired professor of computer science, IISc Bangalore, and distinguished fellow, IDRBT Bengaluru. It says Bangalore, I don't know. Oh, it's now Hyderabad now, okay. So Professor D.K. Subramanian started his career in 1967 as faculty of IISc Bangalore. He also worked as visiting faculty in the University of Manchester Institute of Technology during 74-75, Indian Institute of Management Bangalore from 82 to 86, AIT in 87, and retired professor and dean in 2004. During 1967 to 2004, he has published more than 200 publications and 6 monographs. Advisor to more than 25 years, worked for computerization of government departments, Jindal Vijayanagar Steel, HMT, Mahiti Sindhu Program of Government of Karnataka, Mysore Paper Mills, and other industries, several universities and institutions. Previous associations with the Society of Secretary to Karnataka State University, Karnataka State Council for Science and Technology, 2002-2004, worked as additional secretary to Government of Karnataka. He is also a professor of computer science in IIT Bombay during 78-79. Worked as coordinator to proficiency and extension lecture program of IISc, chairman in power committees, Campus Development Committee, Central Evaluation Committee. Major projects are COWAA project, Department of Space, and other programs is a huge list. Activities are continuing presently in consulting advisor to Tata Consultancy Services, technology advisor to Indian Bank, state advisor to Mahiti Sindhu Program, member of Curriculum Committee of IISc, President in Foundation for Advancement of Education Research, Center for Budget and Policy Studies, presently association with network design and implementation of more than 50 colleges, industries, and institutions. His area of interest are applied system analysis, operating systems, databases, data mining, and education technologies, distributed systems, optimization, and transaction processing. So we have a excellent speaker today, and I call upon Dr. Subramanian to give his lecture.
As a token of our love and appreciation, may I now request our Dean, Dr. Elvin Chandramoni, to honor our chief guest with a shawl and memento. Dr. Subramanian D, retired Professor of Computer Sciences, IISc Bangalore and Distinguished Fellow, IDRBT, Hyderabad. Thank you, sirs.
Good. Thank you. Thanks a lot for all of you. And I've changed the title a bit. What I said is, because it is focusing. What I want to say is, engineering is not technical. Humanize engineering. That's my first point. My second point is, I go from Society 5 to Society 6. And actually, Society 5 happily ignores environment and ecology, which is, I was the professor of Center for Ecological Sciences, so I can't accept that. I want to go for Society 6. I will talk about that. Then as Professor Chandrasekharan and Professor Chandramani said, I will talk about the connected world. Connected world is, I think we have multiple connections. We get connected with electricity first, then communications next, electronics and communications next. Then the computer connectivity came for us with the online systems and commerce. I am expecting to be connected by intelligence in the next level. That may be in another 5 to 10 years. And my focus will be future ready, not future shock. Okay? That's students should understand that. So I would like to start with a couple of quotes. What Darwin says, intelligence doesn't matter. What really matters is adapting to changes. Gandhiji said that, be the change you want. Excuse me, I have to use that thing. Sorry. Okay. So, unfortunately, the pointer has to go there. Unfortunately, as I said, one of the earliest books which looked at both society and technology was by Alvin Toffler. Alvin Toffler wrote the first book, which is called The Future Shock. Then he came with Third Wave, and then he went on with other books. But the most important thing is, fortunately, that was a 70s book, 60s to 70s book. Future Shock was written in somewhere in 60s. And from that we are going to Third Wave, etc. But fortunately, we did not have that future shock. We always anticipated, and we want to be ready for future. So that's what I have been trying to say here. Okay? And I want to remove the confusion between technology and engineering. Most of us do not know the difference between technology and engineering. We confuse both. So engineering is not just technology. Engineering is the application of technologies today, not even a single technology. If you take a pilotless car, it has an IoT, it has a cloud connection, it has an edge, it has a 5G computing, 5G communications, it has image reconstruction, and it has control, it has machines and devices. So it is about dozen technologies which are being put together and applied for building a car which will run on its own without a driver. But that's the idea behind it. So engineering is an ecosystem. Engineering is no more a component. Unfortunately, our division of engineering is one of the biggest mistakes we have committed. This mechanical, electrical, civil, actually I don't know. I'll tell you a simple history. Do you know why when name civil came? Anybody here can give me a guess? Engineering was originally with the military. That engineering was all called military engineering. When you started building roads for the people, they called it civil engineering. And that's how the civil word came in, but somehow it is getting stuck with us even today. So that's the idea with civil engineering. And I think I want to make a small point here. What is connected engineering? What happened? What is connected engineering? You see that we have a large number of sectors in our society. I'm not going to read all of them, but you know we have health, we have, engineering is expanding. Health, education, we have commerce, finance, fintech, when we have government and so on. So all these are connected. You have the people there in the white box, and from that we have a communication system which connects to all of them. So that is the connected engineering. There is also a cloud there where you do the computing. Okay? So that is a kind of a simple architecture of a connected system. Okay? It's a complex system. Okay? We connect the physical system, we connect the virtual system, we connect the cyber system, and now I would like to say we will connect the mental system. That's the next step which we are going through now. Okay? But the data is the universe today. Nandan Nilekani said data is the oil. Okay? But I go one step further. Data is the center of the universe. That's what is really happening. All of us are slaves to data. Whatever people will say, we have all become data driven and data slaves. Okay? So you see that every activity is with data. We are going to become slave for something else, which is AI. Okay, the AI and IT, digital communications. These four are connecting, making us slaves to everything. All our systems, all our activities are all slaves there, all our societies, all our governments. Okay, there is a book called Man 3.0, Human 3.0, which says that, okay, you will become a slave of everything and politics will become irrelevant. I don't know whether it will happen or not. That book shows how politics can become irrelevant. Okay? And there is another book called Cyborg. So you are going to be a meta-human. You are not going to be a human, you are going to be a meta-human. You can have, your body can have a large number of parts inside which are all processor driven and sensor driven. That's what is going to happen. That's what it says. Okay, as I said, engineering is not technical. So I would not go further in that. So you can read it up, because engineering has lots of components like quality, economy, reliability. All these aspects do exist with engineering, which is not technology orientation. The human orientation comes in there. So I'm going to skip that. What is the link between engineering and human? That history I want to give you a little bit, because I have been involved with most of it. I think the first major link between humans and engineering started with computers. The first set of people are programmers. From the programmers, we came to, what's happening? You know, who is blocking that? Here. No, you see here, this is what is connected there, not that. Okay? That's a human link problem. You can see the problem of the human link. Okay, so initially it was programmers. We got the data processing which dealt with accountants. But what it created was a large number of programmers and a large number of systems analysts who were pretty arrogant. When the customer wanted an activity to be done, they say, this is the way I will do it. You will be surprised to know that it is not that in 1970s this happened. Even in 2010 also, 2020 also it is happening. Infosys says take it or leave it. Okay? And ERP came. When ERP came, SAP said that this is what we are giving you, we will not make any changes. So humans are expendable commodities in all these things. So that is the unfortunate thing. The reality of some amount of humanization was done. To me, it is still minimal. See, when the payroll was the first one, we had a lot of problems. So you create a data processing industry, which did the job. Anyway, TCS was very happy that it got a lot of business. That is another. Actually, TCS started with a data processing activity before TCS, which I knew about because I was part of it. Then ERP also did the same. Then I did an enormous amount of customization of CBS, which is the core banking services. All of you use the banking systems. It's all core banking. I did it for at least about a dozen banks in India, including Reserve Bank and including Ministry of Finance. Okay? And Punjab National Bank, Syndicate Bank, Indian Bank here, IOB, and so on. So many banks, including the the latest small banks. Some of them, I did the CBS implementation. Okay, even there, customer wanted something, the implementer will not do that. That's the unfortunate thing. He did the integration. If you take animation, animation has nothing to do with engineering. Animation is more with movie production. Animation is more with artists, with studios. Okay? So you realize that the human link is becoming stronger from a simple user to a completely controlled person like an animator, where I don't think the engineer plays any role. He can't tell them, this is what you can do. He will say, go and jump into the dirtiest pool. That's all what the animator will tell him or the artist will tell him. So that is what, and AI is something else. AI is part of engineering, but AI it needs linguists, it needs psychologists, it needs philosophers, and it needs logicians. So many people. And today, the first lecture is supposed to be on metaverse. Today is metaverse. Tomorrow, you will see that is the world real or is unreal. The famous Shankara's dictum of everything is a myth. You will see it with metaverse. Okay? Well, as I said, engineering was separated. I have talked about it, so I can skip that. Okay? Let us come to Society 5.0 now. I'm not going to define. I think Professor Mani has done an excellent job of defining that. You have heard it quite a number of times. Somebody else is also going to keep saying it afterwards. So I won't do it. But the society understanding for engineering is still very small. That's one of the reasons why we want. I will tell you that, as I said, when the computers came in, the industry went into data processing, business. And academics felt that is a dirty job. That's not something which academics should touch. So that is the kind of situation we have, okay? And that's the kind of situation we have. Same thing happened. The caste system in this is still very strong. That's what was happening. Then I want to tell you something here. There is a person by name Licklider, okay? He in 1951 talked about human-computer symbiosis. I would say Society 5 uses this concept. Human and computer are not two separate elements. There is a synergy, there is a symbiosis, there is a connectivity, there is a collaboration which is existing. That is why robots have become cobots today. Okay? Collaborative robots. That is, I am telling you why I am telling you the year is important to me. 1951. And AI started in somewhere around 1950. 1950, a man whom I know, I don't know him very well, but I have used his machine. Turing, Alan Turing, man whom Churchill said saved millions of lives. Okay, Alan Turing, I used his machine, design machine in Manchester University. Okay, he was also a faculty in Manchester University, not, but at that time I was there much before that. Okay, he was the first one to introduce the concept of Turing test for artificial intelligence. Then 1957, the first AI conference in Dartmouth took place with eminent people who predicted in 20 years AI will sweep the world. I think 80 years have passed by. AI is not to be seen at all. We see only primitiveness of AI around still. Okay? Well, I think this human-computer symbiosis, how do we get it? How do we do that? That's the next question I have here. What's happening? Is it moving? Yeah, it moved. Okay, as I said, I would like to move for Society 6.0. I'll tell you why. The first reason why I want go to Society 5, this is very useful for the industry also, is that our technology absorption is very poor. It used to be many years in the beginning. For instance, I'll give you one example. Tesla was the man, if you are an electrical engineer, he is the man who invented alternating current. And he put up a power plant in Niagara. The year I want to tell you, please catch the year very carefully. 1893. Tesla built the Niagara power plant in 1893. We had a power plant in Shivasamudram in Karnataka in 1903. Just 10 years difference. That technology came to India. The Tesla technology which was there came to India, and surprisingly Tesla put a 50 cycles engine machine, we put a 25 cycles machine. That's the difference between both of us. But in 10 years we did this job. So we should pat ourselves on the back that the time difference is not very high. But this technology absorption is always very slow. We need to improve that. Then I want to give you one current example. The yesterday's example, you all know that AIMS computers were hijacked and then they couldn't get it back. It was all hacked. Okay? And then they have found out AIMS has not done any upgradation of the computers for 30 years. You think it is difficult to hijack them or hack them? So that shows the kind of ignorance. That shows the kind of negligence. Okay? Then I want to give you one more statistics which I am very familiar with. See, many of our industries like TCS went in for digital. About 10 years back we went in for digital. And then we have been talking about digital transformation. Sad news is only 30% has succeeded. 70% is struggling. I won't call it a failure. They are struggling. Why? The question is, I think I just want to read that. The question is that we did not understand the digital and human capabilities and how to match them and how to take care of the human needs. So that is one of the key reasons for 5, because we have been spending a lot, in the organizations are spending a lot of money on that. Okay? Okay, I think I can skip that. That is, he talks about harmony between parts and surroundings. So that's my next approach to environment. That is, I am taking a quote from Rabindranath Tagore. So I want to talk about a few actions which we have done, where I think the society and technology have been integrated. Maybe I can talk about one or two where I think what is it we did that really clicked. The first one is we were using the mud stoves, and their efficiency was 5%, which means every one of us needed one tree every year. So which means we were cutting millions of trees every year. Okay? We were doing 5 to 10 kgs, and so the 5% efficiency, can I convert it to 25% efficiency? Which means I will reduce the wood consumption. I will reduce deforestation. So that is what we did as Asravale, and government took it up and popularized it. Otherwise it would have got through. So the absorption time was 2 years. Not 20 years, but 2 years. We call that as Asravale. That's the first one. The second one is Mahiti Sindhu. That's a program I was a coordinator. Our Chief Minister S.M. Krishna said that 1,000 schools have to be computerized within a year. How do you do that? It's a massive scale. So schools, you can't just put a computer in a school. It's an easy job. That's a technology job. You put a computer, connect them, put a LAN, and then connect a server, finished. No, it doesn't work that way. 90% of schools in the rural areas don't have power. So you have to provide power. They don't have a room to keep these things. So we gave money first for building, then power supply. Then we got BSNL to do the connections. So and then we said we have to train the people. So we trained the teachers. Then we said that, is the program going all right? We did a quality inspection. We put 20 engineering colleges, something like 300 faculty went around inspecting these schools. So that's a very massive activity which we did, which was quite a success. Okay? What was the success factors? Number one, the school enrollment was less than 30%. It became 90%. Two, the pass percentage in SSLC from 50, it went up to 75%. Okay? Number three, attendance became 100%. Okay? So on, and then English literacy went up. So I can say that, but these three are very important points, so which showed the success of the program. Okay, then we had the Bangalore one, which I was also involved, and we call that Sakala. That is, in time, you get all services from the government. You don't have to visit any office, you get this. Okay, this has been running for more than 15 years now. It was offline, now it is online. Okay, so then we have FinTech. We were the first to start the FinTech activity. Actually, we started with Indian Bank here, and I built a device called IMFast, which has been taken, which is mobile, which can be taken to the rural areas, and then you can do the enrollment, and then tell them that your enrollment is done, bank account has been opened, everything you can do that. So that is the next thing where I think people are involved. We introduce a concept of a business associate, okay, who can do that. Some shopwala there, who can do this, okay. That is a FinTech. Then we have a very massive program called NRDMS, covered the entire country. We were mapping all the resources there on digitally and then maintaining them. This we did it for more than 15 years, okay. Then Health Online, all of you know about Arogya Sethi. I was not involved with vaccinations, etc. Smart grids and smart city. Smart city gives you a lot of opportunities. Okay, one can do wonders with smart city, and it's not technology. Let me say that again. It's more of human ingenuity which has to come in there. You have to understand. I was talking to Sudhakar in the morning when we were driving here. I said, why civil engineering is not looking at planning? You see, we design cities without drainages. So every time there is a small rain, there are floods everywhere. Okay? Why? How do you avoid that? I gave an example. We have a very enlightened Maharaja called Maharaja Nalwadi Krishna Jodayar. Again the year I will give you, 1903, when he gave permission for Indian Institute of Science, okay, he was 8 years old. He became Maharaja at the age of 8 years. He gave us permission. Then 1915, he designed a drainage system for Bangalore city, which is city is now reaching to some of the places where the drainage is still existing. He has got such a vision that for 100 years he did 150 years he did a drainage system. Do we have that kind of a vision? That's the question I have here. Okay? So the drainage system is something very important. Garbage collection is another problem we have. Today I think the major problem all of us have is e-commerce. So you see that these are things which are needed. So what we really need is that socio-technical, intelligent, I am using a new term called multi-breed. It's not hybrid. I'm not talking about a hybrid system. I'm talking about multi-breed system. I'm not even using the word fusion, which the Japanese use. I'm using the word multi-breed system because fusion is not possible. You can't put a man into the computer and you can put a computer into a man. That's possible. But you can't put a man into the computer. So it's a hybrid system is becoming, I call it multi-breed system. Okay? So that is what is needed. If you want to move further for the society 6.0, so we are going to move from physical connection to intelligent connection. That's going to be a very tough thing because it's an emotional intelligence. I will not get into the other aspects of intelligence. I will show you my AI gradings a little later. It's an emotional intelligence. That is, I have some emotions. I have anger. The system should understand, act on that. I have a worry. System should understand that. See, even the speech is based on emotional aspects. The frequency of the speech varies with emotions. Okay? So these are the kind of things that, because recognition is going to be a major task of AI. How does it recognize a person? You know, you walk, it doesn't take a complete picture of you and then recognize you. By the way you move the hand, somebody recognizes you. You know a person, first, let's say you have met him for 100 times, even if he is 100 feet away, you recognize him. By the way he walks, by the way his hands move, by the way his legs move. That is recognition system, gesture recognition. So now we are talking about emotion recognition, not image recognition, not pattern recognition, not speech recognition. We go beyond, much beyond that. To be future ready, we have to be that. Okay? We see the careful. So what we need is a socio-technological multi-breed system. That's what I thought it is words of unwisdom.
No, it's words of wisdom, sir.
Thank you, Dr. Professor Subramanian, and it was a wonderful lecture, thought-provoking lecture, and he has gone beyond Society 5, has gone to 6. Probably we'll have a conclave next time. We'll call you.
For appreciation and gratitude, may I now request Ms. Hema Gopal, former Vice President, TCS, Consultant, GenPAC, to honor our resource person, Dr. Subramanian D, with a certificate and memento. Thank you, sir. Thank you, sir. Thank you, ma'am.